Hi, good day once again. This is Engineer Reagan. Today we will try to learn how to get the common monomial factor of a polynomial. Okay, so basically this is just a continuation of the greatest common factor. Um, in the first example that we have 2x squared plus 16x minus 18. So looking at the coefficients 2, 16, and 18, what is the greatest number, the biggest number that can divide all three of them? And by inspection, it's 2. So you write 2. Okay. How about when it comes to the variables, x squared and x? Now, if you noticed, with the variable x, it's not common to all. Why? Because it's not present in its third term, the 18. So basically, you cannot um, consider x as its greatest common factor. So meaning your greatest common factor is just 2. And then after that, you just place a parenthesis. Okay, from this one, from the first term, you have 2x squared. You took out 2. All you have left is x squared. Okay, plus, how about 16? 16, when you took out 2, all you have left is 8. X minus, how about from with 18? 18, take out 2 from it, you get 9 left. So basically, what we have arrived is the factored form of this polynomial. Okay, so what we're actually doing here is factoring. Now, if you want to check out whether you have the right and the correct factors, all you need to do is you just have to distribute it back, because factoring is the reverse operation of distribution, or the distributive property. So if you multiply this one back just to check out, 2 times x squared, you will have 2x squared, plus 2 times 8x, you have 8 16x, and then 2 and minus 9, you have minus 8 18. So see, it checks out. So basically, these are correct factors. Okay, let's have another example. Okay, here 3a cubed plus b4 plus 12ab cubed plus 18ab to the power of 5. Now again, looking at the coefficients, 3, 12, and 18, the biggest number that can divide all of them is 3. So you put out 3 as the greatest common factor for the coefficients. How about with the variables? You have here a cubed plus 12a, and on the third term, you have another a. So as I've said before, the greatest common factor for a variable is you just have to choose the one with the least exponent. And the least exponent here, the variable with the least exponent is actually a. So that's it. How about with b? With the variable b, the one with the least exponent, okay, the first term you have b to the power of 4, second term you have b to the power of 3, fifth, the third term is b to the power of 5. So basically, among the three of them, the one with the least, the smallest exponent is the b cubed. So that becomes your greatest common factor. Okay. So from here, from this term, take out 3 and a b cubed. What do you have left will become, as for the a, this becomes a squared. Why? Because from a cube, you took out a, you will have a squared left. How about with b? From b to the power 4, you took out b cube, all you have left is b. Plus, how about with second term? For the second term, from 12, you took out 3, all you have left is 4. From a, you took out a, okay, you don't have to write a anymore. How about with b? B cube, you took out b cube, again, you don't have to write for b. All you have left actually for the second term is just 4. For the third term, you will have 18 a b to the power of 5. 18, you took out 3, all you have left is 6. Right? Okay, from a, you took out a, no need to write for a anymore. How about b to the power 5? From b to the power 5, you took out b cubed, all you have left is b squared. Okay, this is now the factored form of the given polynomial above. Okay, once again, if you want to check it out, you can distribute this factor back to each of the term. And you will see that after doing so, you will go back to the original expression. Okay? Another example. How about this one? Very quickly, 35, 21, and 14, all of them, the biggest number that can divide them is 7. So you place 7. How about with x squared, and x cubed? Okay, write the one or take out the one with the least exponent. So the least exponent by inspection is x. When it comes also to y squared, y cubed, and y squared, the least exponent is y squared. Okay, after that, you're already done with the greatest common factor. Next is the parenthesis. For the first term, okay, from the 35, you took out 7. All you have left is what? You get 5, right? Okay. How about with the x? X, you took out x. No need to write for x anymore. And also for y squared. So for the first term, what you will have left is just 5. Last, for the second term, you originally you have 21. You took out 7. You will have 3 left. Okay. Actually, all you need to do here is just divide. 21 divide 7, you get 3, right? X squared divide x is x. Y cubed divide y squared is y. Okay? How about 14? For the third term, you took out 7 or divide 14 by 7, you get 2. From x cubed originally, you took out x or x cubed divide x, you get x squared. How about with y squared? Y squared, you took out y squared, meaning you don't have to write for y anymore. Or y squared divide y squared, that's just 1. So basically, we now have the factors, okay, of the given polynomial above. Okay, let's go to our fourth example. Our fourth example doesn't have any coefficients to its terms. So basically, this is much easier than before. So first, okay, let's directly move to our variables. A squared, a cubed, and a5, a power of 5. List down the one with the least exponent, and in this case, it's a squared. How about with b cubed? B cubed, b to power 4, and b squared. The one with the least exponent is b squared. How about with c? You have c squared, and c cubed. The least is c. All right? And then parenthesis. Once we have already taken out the greatest common factor, what we will now have is the other factors. So for the first term, originally you have a squared, you took out a squared, okay, that cancels out. B from b cubed, you took out b squared, you will have b left. How about with c? C, you took out c, okay, so meaning for the first term, only b is being left out. Minus. Okay, for the second term, you have a cubed, you took out a squared, you will have a left, right? Or a cubed divide a squared, that would be a. For the variable b, you have b power 4, you took out b squared, you will have b squared left. How about with c squared, you will have c. Last, okay, again, for the last term, this one, originally you have a power of 5, but you took out a squared, you will have a power of 3 left. Okay, and then b squared, okay, that cancels out c squared. Now, if you've noticed, when it comes to the variables, when you took out already the greatest common factor, all you need to do actually is just subtract the exponents. If you've noticed here, from this one, the second term, you took out this one as the greatest common factor. See, what do I have left? A cubed minus a squared, I have here a power of 1. See? When it comes to b power of 4, I took out b squared, so I have left what? 2. Why? Because 4 minus 2. That's why I will have here b power of 2. When it comes to c as well, you have c power of 2. This one automatically has 1, right? So 2 minus 1, that's why I will have here c, having an exponent of 1. All right? So that's how easy is it. Okay, lastly, our last example. You have 3m squared plus 12m minus 15. For the coefficient, the greatest number that can divide all three of them is 3. So the greatest common factor is 3. How about with the variable? Okay, the variable doesn't have a greatest common factor. Why? Because the variable m is not common to all the terms. So basically, our greatest common factor is only 3. So basically, the other factor is m squared plus 4m minus 5. Right? So that's all. I hope you were able to understand how to do the factoring by greatest common factor. So that's all, guys. Thank you. Bye.